thank you so much for coming out either in person, which is great to see everyone, and then online as well. I know we've got folks across the country and even the world, so really appreciate this opportunity. I really enjoyed giving a different version of this talk last year, and I will say the most challenging thing about this year's talk is deciding when to stop adding content. Because you could imagine, like last night, I was trying to like finish the last slides, mostly done, and sure enough, there was a tweet at like 11:30 or something.
Steve?
Yeah.
We're having one small problem with the presentation. It's too small for the online audience. So hold that thought just for a second.
Sure.
I am going to try to get out of that mode.
All right.
Keep going and we'll work on it from here, Steve. So
Okay.
Thanks.
All right. Well, anyway, what I was saying was that, as you're probably aware, if you came to this talk, that things have been a little crazy in the AI world recently, and it seems like it's gone even faster. So I really appreciate the opportunity. So AI is such a huge field. No one person obviously knows about every part. A lot of folks from KUNGFU.AI have helped contribute ideas and content for this talk, as well as our advisors, people in the community. And so, I really look forward to the questions at the end and then chatting at the event afterwards. Just know also that, of course, we're going to make both the slides, presentation, the recording available as well. So don't feel like, oh my, that you have to like take screenshots of any particular slides. We will make everything available, and I'm happy to have follow-up discussions with anyone after the event tonight or then beyond that. So with that said, let me just take a look. We're just going to talk a little bit about some basic terminology, give a lightning-like introduction to AI and machine learning, obviously talk about a lot of the recent exciting developments in AI and ML, and then of course also spend a good amount of time talking about the risks, because as we know, it's really important to keep those in mind for all these kinds of technologies. So. There we go. So, all right, there we go. So just by way of background in terms of about me, I was born and raised in Los Alamos, New Mexico, where the national lab is. So hence the whole geek factor. So I did my PhD in physics at UT Austin. I finished that 30 years ago in chaos theory and nonlinear dynamics. And basically I've had the wonderful opportunity to basically translate that career in science into transitioning now into work in AI and machine learning. I've been happy to be part of the board of technical advisors for Data.World. And then I wanted to especially say that we are especially grateful at KUNGFU.AI to be contributors to the organization, and Stephen Strauss, who is our managing director, and I are on the board, and we're happy to serve in that capacity. So let's see if we can head on. Is that working? There we go. So, okay. So anyway, so obviously, so artificial intelligence, basically the idea is the field of research that relates to training of whether it's machines or computers to handle a variety of tasks that would normally have to be handled by humans. So some aspect of cognitive ability or thinking ability. So as we talk about that, then we can move into the subset called machine learning. So basically where we design different kinds of systems, and we'll talk a little bit about the various flavors of machine learning in just a few slides. But basically the idea where you have systems or algorithms that can be shown training data, can then learn from the training data in order to make predictions or classifications or other kinds of discoveries that will be useful. Then deep learning basically is a subset of that, where basically we're building up basically large systems of artificial neural networks that were originally inspired by the human brain, neurons, the connections in the human brain, to do those even more tasks, like whether it's classification, time series forecasting, anomaly detection, a lot of those kinds of application areas. So with that said, this is kind of the hierarchy. So where AI, and right now, so AI is the largest set, machine learning is a subset of that, then deep learning is an even smaller subset of that. Now, it'll be very interesting to discuss, for example, at the event afterwards, there are lots of debates. So what's called AGI, or artificial general intelligence, is something where it's kind of like always been viewed as something way out in the future. Now, some of the recent advances seem to indicate, well, that there might be some ways in which we might be getting a little bit closer, but broadly, most of the recent advances in the last, say, 10 to 12 years have more been in the area of what we call narrow AI. So for a specific task, for a specific application area. So in terms of classical machine learning, these are kind of the major subsets that we like to talk about. Supervised learning, so that broadly relates to showing the algorithm a set of known examples, what we call ground truth with labels. And then you train the system based on those known examples with ground truth information. And then you have a subset of the data set held back as test data that you see, okay, how well it can do doing some kind of prediction, whether it's a classification, a detection task, or so forth. And then we have unsupervised learning, which is basically trying to find the patterns in some unsupervised way. So finding out what the clusters are in data and so forth. So those are those kinds of examples. Then there's sort of a middle ground, which is semi-supervised learning, where you might have a few labeled examples, but in most cases, the vast majority of the data sets are unlabeled. And that is quite realistically, a lot of the real world falls into that semi-supervised learning. And then, as we'll see, if you heard about ChatGPT, reinforcement learning, it turns out, is going to be an important part of that. And so that relates to basically building up a system where there's a reward feedback. You have some kind of end goal, right? And you're going to train the system to learn from the environment, have something called a policy, and a way, or basically a way for the system to evolve over time to achieve some end goal. So once again, you'll have the link to the slides, but those are kind of the broad general categories that most folks tend to talk about. And once again, there's some cool things. So once again, the nice thing is that I think it is way easier now to get up to speed on AI and machine learning. There are so many resources available online. So even in terms of classical machine learning, there's something called scikit-learn. So this is just one of the examples that kind of shows that if you're starting into AI or machine learning, there are lots of great resources. If you have any questions afterwards, I'm happy to give more advice about that. So why now? So obviously, what has changed that's made this a lot more achievable? Because the earliest sort of advances in terms of artificial neural networks were from decades ago, right? But one is, of course, just the fact that we have way more powerful computational hardware available. So this is kind of shows the progress. That's from 1970 to 2015, and that just kind of shows the increase in computational power. Same thing with GPUs, which of course were specialized computer kinds of chips and hardware, I think originally geared towards things like video processing and gaming, but have been really used to great effect in deep learning. And then hardware has continued to evolve. And so I have some, Paco Nathan, who's a longtime friend and one of our advisors at KUNGFU, has really kind of been involved in many aspects of machine learning for decades. And it's kind of really talks about this confluence of computational power, and then we'll see data coming into it. So as we evolved, in fact, I think, Jay, when you and I first met, you were the director of the Advanced Computing Center at UT Austin Balcones Research Center, when it was all about, MPI, multiprocessor, back in the 1990s. And then through the 2000s, we kind of evolved talking about Hadoop and Spark and MapReduce and so forth, which were certainly powerful in their times, but really now we've really evolved to Apache, Anyscale Array is one of the really promising new technologies, and there have been many advances in terms of other kinds of open source tools. So I think we really have now a confluence of all those things in terms of ability, but also data, right? Obviously, we know just online, the amount of data available for these systems is just absolutely sprawling. So basically, data being the new oil that can go into these systems. And then finally, the great thing is that whether it's universities or large corporations, there's been a lot of effort put into making open source software available. So these are kinds of things that you tend to think about or tend to hear about in machine learning, TensorFlow, Keras, PyTorch, many of which have just been made available completely for free. You might have heard of Hugging Face. That is certainly a very key company or organization to be aware of now. And so just this kind of shows the absolute growth in popularity of these various frameworks. So really, we have way more computational power. We've got data available. We've got open source frameworks. So really, that is what made it possible, in particular, combined with algorithmic advances. And we'll talk about the different flavors of deep learning systems that we'll see. But bottom line, even though that the original ideas for networks came out, decades ago, now finally we have the computation, we've got the data, we have the open source frameworks, and the algorithmic advances that make it possible. So this would be just a kind of a typical deep learning architecture. As I said, a lot of times we have a training data set. We might have, this is very simple, just with a few layers. We have an input data set here. We have some hidden layers, and then we're typically trying to make some kind of prediction. And we have, in this case, ground truth information, and we're trying to see how well are we doing. And what happens is in deep learning training is that we're training a loss function to measure how far off, basically how well the system is doing. All right. And so this is the typical mechanism that we go about when we're training a deep learning system. This step of back propagation you might have heard of basically means we're going to adjust the parameter system, the weights and the biases, so that over the time the system will do better and better, whether you're trying to do classification or prediction or some other task. So we'll talk just a little bit now, just to give folks an introduction to the kinds of neural networks there are in deep learning. So CNN architectures, convolutional neural networks, these tend to be used a lot in computer vision applications. So think about anything, when you think about images, you have a regular grid structure at different scales as well. And so typically these systems have, once again, different layers, and typically in a CNN neural network, you have the different layers which pick up different parts. For example, some layers in the network will pick up edges or corners. And so by building bigger and bigger systems like this, we can really provide a lot of value in terms of, like, when you open up your phone, if it's trying to do face recognition, that's because a deep learning computer vision model has been built in. So CNNs, that's for typically for regular structures. So recurrent neural networks, basically where we have loops, those kinds of systems are really set up to handle sequences of data where there's an ordering, a structure. You think about language, what happens is an order. You say words in a sentence in a particular order to make sense, or time series, right? If you think about trying to predict stock prices, there's an order to that. So recurrent neural networks were used quite a bit for those kinds of problems. Then 2017 happened, something called Transformers. So not the movies, right? But Transformers. So really, I think it's probably, in terms of deep learning, the most revolutionary of the architectures that we've seen. It was originally developed back in 2017 for natural language processing, or basically understanding text. But since then, it's actually been adapted to computer vision, to anomaly detection, to graph neural networks as well. This is from, I had meant to actually check to see how many citations there were. So last year, there were 39,000 references to this paper in 2017. So now, of course, later tonight, I have to go back online and check to see how many it is, how many of that, but that's pretty amazing where you have 40,000 references to the single paper. So, and which was like, attention is all you need. So we'll talk a little bit more about what's involved here. So one of the prototypical examples where transformer architecture is used is machine translation. So you have a document in English, and you're going to translate it to French or vice versa. So if you've ever used Google Translate, transformer architectures, that's definitely what is used behind the scenes. So the cool thing is the whole attention mechanism basically relates to the ability of the system to figure out what parts of the sentence are conveying meaning. And as we know in language, you have to keep track of things that have been said before, right? So in this example, the machine translation example, this is from French to English, or sorry, English to French. The animal didn't cross the street because it was too tired. And so that is here. So the question is, what does this it refer to, right? Because you can imagine there's this, the noun is animal and there's another noun street. So does it refer to animal or street? All right. So that is the challenge, because in French, animal and street have different, let's say animal is masculine and street is feminine. And so when you translate, you have to know whether it's going to be il or el after the translation. It's a cool thing. So this is, I thought, a really cool diagram, because here, basically the model learns the strengths of the connections to previous based on all this massive training data. And so is able to predict what the correct translation of it is. In this case, it knows that it was too tired refers to the animal. And so it uses the masculine pronoun. Similarly, the animal didn't cross the street because it was too wide. Well, in that case, it refers to the street. And so this shows, based on massive amounts of training data, the attention part of the model figures out that it refers to the street, and that way it can actually find the correct version of the pronoun. So if you think about transformers and attention, the attention part just relates to figuring out what part of the previous conversation is important in order to predict the next, to predict whether you're trying to predict the next word or figure out where the correct translation is. So over that time, there have been lots of advances, and sorry, I actually meant to go back here. It turns out, so for the original transformer model, we have both an encoder and a decoder parts. So it turns out when many researchers went on, so some versions of the transformer models use only the encoding part, things like BERT, if you've heard of BERT, that falls in this line. Decoder owner, this relates to, for example, GPT, which we're going to hear about more later on tonight. And then there are parts, the version of the model that incorporate both Even think about biological examples where you have different kinds of molecules or proteins connected to each other. So graph neural networks are incredibly important in many kinds of these applications. So telecommunication networks, computer networks, biological ones. We don't have a lot of time to talk about this today, but I highly encourage you, and I can send you, if you're interested in this, send you even more references. But it's absolutely just a fascinating area of research. And there are a bunch of references. So my friend Paco Nathan is definitely an expert in this realm, and we have some really interesting references if you want to dive into that more deeply. Knowledge graphs. It's kind of an extension to GNNs where we have types of connections, but we're also basically embedding knowledge about a system. So you think about when you have a manufacturing plant, you have different kinds of ingredients that go into building a product. And so there are relations between, you know, types of ingredients, for example, in that case, but you also might have dependencies in terms of when things have to be added together to in a process. And so knowledge graph basically is a way of encoding all of that information about a system. So it's a really powerful construct, and it's used in many industries already. So that is a lightning-like introduction to machine learning and AI. As I said, I hope that gives you a little bit of grounding, and it's just fascinating to now move into the kinds of application areas that in AI that we're seeing. So obviously reasoning and discovery, think about fraud detection, asset management, product and media recommendations. So think about when you go to Amazon or Netflix. These are real world things where the system is building up recommendations so that based on what you have liked previously, or even Spotify, like it's really powerful. Those are big recommender systems. And Brent, I know we can talk about even like when you go to things like HomeAway or Verbo, there's a lot of things about in terms of what kind of listings you'll be shown. Planning and optimization, especially think about everything that happened during and after the pandemic, or at least the worst parts of it. Think about all the supply chain challenges. What happens when parts of the network are destabilized? And so supply chain optimization, that's a really big challenge, and that's another focus area. Perception and communication, think about medical imagery analysis, voice recognition, language translation. We talked about also autonomous vehicles. That's going to come up later when we talk about ethics of AI systems. And then this, of course, is you're going to see later, fairly soon, what we'll be talking about in terms of creativity, being able to generate realistic images, generate music, going from text to images, some incredibly powerful advances just in the last several months even. It's really amazing. So this is kind of a cool slide, and a big shout out to my friend and colleague at KUNGFU.AI, ZZ Sai, one of our co-founders. And so he found this example, kind of seeing basically like generating images of cats starting from 2017, where, gosh, that looks, pretty darn bad in comparison, right? Right? 2019, yeah, pretty good. Like, okay, 2021, well, it's pretty darn. And of course, now this year is like hard to distinguish that from an actual real world cat. So that's just an example about how things have progressed over the last several years. So generative AI. So I decided, well, what the heck? Let's put ChatGPT to use. So I asked ChatGPT, what is generative AI? So it's a type of AI that involves creation of new and original content, data or content, such as images, music, text, or even video using machine learning algorithm. Of course, I'll let you read that later on, but it did really well. But broadly, it relates to being able to create new examples given amount of, based on training data. So this is just a massive amount of different kinds of generative AI models. So think about text to image, things like DALL-E and Stable Diffusion. We'll talk about text to 3D images, 3D objects as well. Image to text, pretty cool advances there as well. Text to video, text to audio. We'll definitely talk about some examples there. And then translating text to text. So think about ChatGPT, where you ask it a question, it comes back with a response. That is obviously a text to text kind of problem. Text to code. Obviously, I think a lot of software programs are both impressed by and potentially, understandably a little bit concerned by the code generation abilities of some of these recent models. And then we have text to science. So a lot of different kinds of generative models, most of which are created by a very small set of very large corporations. So we think about OpenAI that has ChatGPT, Google Research has quite a few of them. DeepMind, and then Meta, of course, part of formerly Facebook, and then Stable Diffusion is actually related to created by a company called Runway, and then NVIDIA, of course, has their own kinds of models. So, but as you see, just because of the massive costs associated with building these models, you really need large budgets, large teams that are not available in general for many organizations or universities or nonprofits. So I'd like to talk a little bit more now about some specific examples. So you might have heard, or last year we talked about DALL-E being a generative AI model, class of models for creating images. So kind of since then, we've had a lot of progress, something called Stable Diffusion. So if you're interested, we'll kind of walk you through how that works. The idea here is we want to take a text like Paradise Cosmic Beach, and then you want to create an image. So what goes into that? So basically, you have to have part of the system understand what was requested. So there's a text understanding piece, all right? And there's also an image generator piece. So going down to the next level. So once again, this text encoder is based on the CLIP model. Basically, when you think about the internet, a lot of times you'll have like images of cats. You'll have an image and you'll have tags or labels like what's in it, so that the model learns an association between text and image. So it builds up that understanding. When you say this word, this is what that looks like. These are what cats look like. This is what dogs look like. Then that's fed into this whole diffusion set. And this relates to basically building up the image. And then we'll talk a little bit more about this diffusion step, but at the end, the output of that whole system is put into an image decoder, right? And then you create the final image. So what goes into that? Well, basically, my understanding is that, and there are folks on the KUNGFU team who can tell you way more of the details, is that when the system is trained, we start with a real image, and we add different amounts of noise, Gaussian noise. Think about blurring or basically adding some randomness to it. And then this UNet architecture learns what that noise pattern is and learns how to remove it. So basically, what happens is, what we see here is this progression. We can start with basically a noisy background, and we give it a text prompt like this beach scene, and you'll see as the system progresses, it essentially peels away the noise and results in an image. It really is kind of fascinating. And the cool thing about, so these are some examples from the 22 paper about Stable Diffusion. So this one is an oil painting of a latent space. And that's just created. Give that text, and that's the image it generated. And the one on the right, an epic painting of Gandalf the Black summoning thunder and lightning in the mountains, which is really pretty impressive. So I was just really fascinating. The cool thing about this one, this whole diffusion step, is originally, my understanding is that the earlier models like DALL-E operated were actually on the actual pixels of the images. With Stable Diffusion, what it does, it projects everything into a much smaller dimensional latent space, they call it. And then it operates entirely in that latent space. And so Stable Diffusion is a way faster. So it's kind of interesting that essentially it learns this clip, the original clip model figures out pairing between text and images. The unit part in the middle figures out how to remove noise. And then basically when you ask the system, give me a picture of X or Y or Z, it goes into this vast representation of text and image and knows how to remove noise. So you think about like one way I thought about early this morning is think about just like a block of wood, and you tell it, I want a statue of this, and it knows how to carve away the noise to generate that image. So it's really pretty fascinating. So that is the essence of Stable Diffusion. As before, there are tons of further details we can go into, but I think this process here is just fascinating that happens naturally, that it peels away the noise to generate that. Language. So this slide kind of shows just all the massive language models that have been, this was through the end of 2022. The bubbles kind of show how big they were. If it has a solid outline that is a closed model, basically the creators did not open source it, make it available completely to the community. And then this one came out on March 31st. And this shows, once again, this is 2019, 2021. Just look to see how much has been just released all in 2021, 2022, right? And just right now, here's where we are in 2023. ChatGPT came out the end of 2022, and GPT-4 came out very recently. So in my view, this is just like an absolutely breakneck kind of development in terms of both these large models. There we go. So GPT-4 came out. The interesting thing was GPT-4, generally purpose transformer model. So we don't know exactly how big it is. OpenAI has not open sourced it. So we know it is way bigger than 3.5. Some folks have estimated it's roughly 10 times as big as GPT 3.5. But this slide here kind of shows how much better it is. So the blue part is GPT 3.5. It is way better. And these are things like at English language exams, the bar exam, so really, really impressive performance on all of these exams, right? So, so probably both impressive and scary in some cases. And so naturally, there's just now a huge amount of interest. So obviously companies are figuring out, oh my gosh, we got to get into that whole ChatGPT stuff, right? And then Google came out with its own. So basically there's a lot of competition right now. So OpenAI, which was funded in part, Microsoft invested a lot of money in OpenAI. But Google, of course, has been very, very prolific in deep learning. And so they are coming out. The thing is, the language models themselves are typically frozen based on what they were trained on. So I think GPT 3.5 was trained up through the end of 2021. So it doesn't know about things beyond that. Now with ChatGPT plugins, the models can actually connect to the web and can learn. And we'll see here just shortly some both interesting and some scary examples of how they interact in the wild. So how does ChatGPT work? So basically the models are, once again, we're going to train a large language model to complete text. So think about here, and by the way, huge thanks to my friend and coworker Reed Koch for these wonderful introductory slides about ChatGPT. Yesterday I went to and then we have some predictions. Like 20% of the time it's party, went to the gym, went to the mechanic, went to the store, right? What's most likely? So basically the model learns to predict the next token in the sentence. All right. The next step is to fine tune the conversation. So basically the example here that came up was, I would like to eat healthy tonight. What could I make? And so there are various options here, order McDonald's, I'm not your mom. Some options, try to go salmon. So basically there is some goal, right? So the model is going to learn some goal about healthy eating, right? And so it's going to make suggestions based on that. But then the cool thing about this, and this goes back to that earlier slide around reinforcement learning, this ChatGPT references a really fascinating combination of a traditional deep learning system with reinforcement learning. All right. So basically, when the model learns, it's going to come up with some options. And when the model was trained, what they did is they showed examples to humans and asked them to rate how useful the responses were. All right. We got a new AI fan back there, very young, starting early. I love it. And so basically, it ranks them based on usefulness. And so the model then can go back. So essentially, once again, this is still broadly in this encoder decoder kind of scenario. We have input text, the model encodes it into a much smaller dimension, a set of dimensions, decoder, result in some summary. So, but really the thing that's distinct about ChatGPT is we're fine-tuning the results based on human feedback. There are a lot of details here about the reinforcement learning piece, where basically, obviously, we're going to train, train it based on, the humans that were involved in the training. Here's some examples. There's a part of the model that learns, okay, in general, when we show these kinds of responses, these are the ones that are useful. And then in practice, obviously, when you use ChatGPT Live, there aren't humans behind trying to rank the choices. What happens is that they've now built a reinforcement learning model based on all of those responses. So really, really fascinating combination of different kinds of machine learning, I thought. Interesting thing here, I don't know if you can see it. So this paper came out. This was the Instruct LLM paper, came out last year, already cited by 422 other papers. So that just, once again, gives you a sense by just about how quickly the field is moving. So think about, once again, what are the kinds of things you can be used for? It turns out to be really awesome at, here are these figures, can you make a table out of this? Like reformatting, it turns out to be great at that. If you want to, have an idea, like you have an idea for a story that you want to write, anything creative, write me a story about X or Y or Z. It can, based on everything that's been trained on, it can come back with some really awesome suggestions, think like of initial draft. But as you can imagine, and we'll talk a little bit more about this later, you could obviously use the system in very negative ways, right? As a bad actor, pretend that you're mayor of Whoville, write a press release that Christmas is canceled. Pretend that you're a doctor. Is it safe for me to take 500 milligrams of oxycodone? And folks, if there have been some safety mechanisms built into ChatGPT, but people obviously try to game the system and try to get it to do things that it was not supposed to do. So basically, once again, and this is just a preview of the responsible AI and ethical AI section, is just important to know who owns and benefits from the definition of useful. So once again, those are bad. So just we saw the example of how much better GPT-4 is at passing things like bar exams and so forth. This was an interesting example, and shout out to Dr. Jonathan Mugen of Diumbra, and he's one of our advisors at KUNGFU.AI. So the example on the left is GPT 3.5, on the right is GPT-4, their response. And just kind of reading in case it's not clear. So the question is, the setup is, I'm in my house, on top of my chair in the living room is a coffee cup. Inside the coffee cup is a thimble. Inside the thimble is a single diamond. I moved the chair to my bedroom. Then I put the coffee cup on the bed. Then I turn the cup upside down. Then I turn it right side up and place the coffee cup on the kitchen counter. Where is my diamond? So GPT 3.5 thinks that it's still on the kitchen counter. GPT-4 says when you turn the coffee cup upside down on your bed, the diamond inside the thimble would have likely fallen out onto the bed. The diamond is now on your bed. So that is the difference between 3.5 and 4.0. Now, there is a very vigorous debate in terms of, does this mean that GPT-4 has a worldview? Like, does it have an understanding? So broadly, a lot of the earlier versions of GPT-X were trained only on text. GPT-4 was trained on text and images. So it appears to be learning something about the world, but we don't know what. So it really is a huge debate that's going on in terms of machine learning, in terms of what is the extent of what it knows. But as I said, potentially both impressive and slightly might be concerning as well, understandably. When you interact with these systems, there's something called, you might hear prompt engineering. That basically there are ways of prompting the system to get better responses. And so it turns out, imagine is a great word. And this is by a researcher, Pete Skomrock, who's very famous in machine learning. He used to be a leader at LinkedIn and many other companies. So he said he went to brainstorm, use the word imagine in your prompt. But it turns out that you can also do things like analyze the impact of, or explore the nuances of, discuss the effects of X on a specific aspect, critique the arguments for and against. And so you can prompt the system to, in all of these ways. So once again, I think it's really exciting that you can essentially use this super large trained model to explore, come up with ideas, come up with content. But once again, we'll see later on, don't rely on it to like make medical decisions. Anything sort of with high stakes decisions, I think is really important. Since then, obviously, so even this is very recent, just came out on March 30th, Bloomberg GPT. So basically, broadly, what we're seeing now is fine-tuned models on a particular use case. So finance, so Bloomberg GPT just came out. ChatGPT, I say Chat Doctor, so medical chat model fine-tuned on one of the large language model called Llama using medical domain knowledge. So once again, lots of good potential, but as you imagine, the potential for getting things really wrong. And so once again, heightened risk. A cool example from late last year was using language models to predict the basically the potential effect of COVID variants. It turns out these language models did really well at coming up with early warning signals for different COVID variants. So the red line was when the system gave an early warning. The green line is when WHO designated that variant as concerning. So some pretty impressive results there. Since then, as I mentioned earlier, a lot of these large deep neural networks have been trained by very few. Think about Google, Facebook, OpenAI, Meta. But fortunately, there's been a lot of advances now in terms of training neural networks faster on smaller hardware. So if you're interested in that, I highly recommend. So this is thanks to Barry Dauber and the Mosaic ML team. They've done a lot of work to open source libraries that basically help you speed up machine learning training. So if you're interested in that, I can definitely connect you with them. But a lot of that is completely open source. They also have a special cloud version that makes even more features available. So really important resource there. Music, obviously we've talked about images, we've talked about text. Well, here's another example. You can generate music. And interestingly, you can generate music by just giving it text. You can give it music by humming. So you think about an audio prompt and it will then create music based on that. You can actually even show it like a painting, right? And then it will generate music inspired by that painting. So I think the painting as well as the painting description. So really pretty interesting. Unfortunately, I don't think we were hoping to maybe play some examples. I don't think it, but when you get the slides or just Google music LM, you can check out. They even have long samples as well. So pretty impressive. So I hope that those examples of some pretty impressive results for image generation, for text generation, or understanding music as well. Obviously, people have done stuff even for videos as well. In case you're interested, once again, it comes down to a fascinating combination of building part of the model here, part of the model to basically understand music, the auto piece, and then the text, and then essentially fusing that together in what's called audio tokens. And then when you are prompting the system in inference, you can basically decode that into an actual musical sample to play. It's a really fascinating, very creative result, I thought. Just a little bit more detail there. So I think it's a really exciting time. I've been super impressed by the results of these very recent systems. But of course, as we know, there are certainly risks. So these are just some of the areas that come to mind: security and robustness, privacy, fairness, broadly ethical concerns. We've talked about before, how about the fact that these models are super large. So it takes massive amounts of training. So there's definitely an environmental impact as well. We'll see a little bit later on, misinformation, disinformation. Well, when you can create realistic text, video, and audio, well, that's just a recipe for more misinformation and disinformation. So it's a huge challenge. Deep fakes related to that. Also copyright violations. You think about all the photographers, all the musicians whose work went into training these systems. And so there are definitely ethical considerations. Well, how are those people going to be compensated by that? Negative effects on impacted populations and industries. So I can share more links later on, but it turns out when ChatGPT was trained, they hired workers in Africa who were paid very low wages to do that kind of work. There's definitely a concern around economic fairness as well. Risk of eventual Skynet-style AGI. So we'll talk a little bit more about that in sort of the 6-month pause later section that'll be at the end here coming up in just a bit. Obviously, security and robustness. We've seen that a lot of these systems are vulnerable to attack. So it's really important to design the systems so they can be secure and safe as much as possible. Privacy considerations. And so this is interesting because there can be a trade-off between privacy and performance, right? So you think about anything related to medical AI, well, it's important to keep the source data private, but if you can fuse the results of training across multiple data sets, this is something that we've at KUNGFU have had the chance to do. We're working now in breast cancer detection, doing that for the last 18 months. And that is basically we're training separate models based on mammogram data from separate hospitals and using something called federated learning so that you can never go back and reconstruct the original training data, but you can get a better prediction, basically coming up with the risk of breast cancer 5 years down the road. And so fingers crossed, we're in the process of helping that company, that client, go through FDA approval. Fairness considerations. Well, it turns out you think about fairness, well, there are a lot of subtleties there, different kinds. There was basically in 2018, this researcher professor came up with 21 different variations. Think about group fairness, individual fairness. Was this fair on an individual basis, or are we trying to achieve some level of fairness for different groups? And so they're just really important things to keep in mind. Some of the use cases that come up to mind: college admissions based on SAT scores, mortgage lending decisions. So it's really important. And unfortunately, there are some examples where if you train models based on the historical past, then essentially the inequities from the past will get propagated. You think about economic viability. If there have been parts of the community that historically have been lower income and so forth, then those can get propagated unless you make efforts to make sure that the eventual model is less biased. So just important point to keep in mind, and you really have to keep those things in mind from the beginning of the project. Like you can't fix it at the end. You have to think about it at the very beginning. Types of bias, just tons of things to keep in mind. You know, once again, you can't eliminate it completely, but you can, based on the goal of the system, you can actually make a lot of progress to reduce the bias. This comes up a lot in healthcare, where typically a lot of the data sets come from wealthier parts of the world. And so they're just fundamentally, there are more training examples for wealthier parts of the world and less for well-off. So once again, and we had to do this for that breast cancer detection stuff, and you actually have to show to the FDA that your models are not negatively or disproportionately negatively affecting groups where there are less training examples available. So lots of statistical methods and bias reduction methods that go into that. If you're interested in that, I can definitely give you a lot of more information about that. Fortunately, there are some open source fairness tools. There's one called AI Fairness 360 from IBM that basically is meant to help researchers and folks who are deploying these models to, as you go through this process, to make sure that the models are as fair as they possibly can be. Google has a ML fairness gym. As we know, the world is not a static place. Things change over time. So even if you have a model that starts out doing well, if the underlying, we know the underlying world changes, so it's important to keep updating the model. And so the fairness gym is just one option to keeping track how the model does over time. And so this is a really interesting example. This came out in 2018. And it really brings the fact that the consideration that it's not just about the technology. It's about taking into account the larger cultural, societal implications. So the use case, broad use case here is an autonomous driving. The vehicle's moving along. There are obviously passengers in the car. You've got the driver and maybe passengers, and you have pedestrians. And the situation unfortunately happens where an accident is unavoidable. Now the car, the self-driving car has to decide to spare the passengers or to spare the pedestrians. And so they did a very large worldwide survey based on different parts of the world to see, sparing the lawful, sparing the fit, who basically are the people, like, did they cross the street illegally? So it turns out it's very interesting. If you're interested in that, I really encourage you to check out that article. And that really just goes back to, once again, that it's not just about the technology, it's about understanding the larger ethical and cultural implications. So, broadening up the perspective. And so that's one of the things that I really like about the Austin Forum, is that we have these opportunities to take these kinds of very, very important questions and talk about them. In 2020, a great paper came out, closing the AI accountability gap. So basically coming up with an end-to-end framework for internal algorithmic auditing. And so the important thing is that this kind of model broadly relates to designing AI systems from the beginning to be as fair and equitable as you possibly can. So we try to definitely incorporate this kind of work. So thinking about use case ethics review, social impact assessment, are there possibilities where some segment of the population will be negatively impacted by the system, and try to think about that at the outset so that you can try to minimize those effects. Model cards, basically documenting how the model was trained. Data sheets, when the data sets were collected, was that done in a fair way? Were you able to try to mitigate any bias in terms of the way the data sets were collected? And so it's a really, really powerful framework, and one that I highly recommend that organizations who work directly in machine learning take into account. And so I thought this was just a really great quote. I'll take a moment to read here from that paper. AI has the potential to benefit the whole of society. However, there is currently an inequitable risk distribution such that those who already face patterns of structural vulnerability or bias disproportionately bear the cost and the harms of many of those systems. Fairness, justice, and ethics require that those bearing these risks are given due attention, and then organizations that build and deploy artificial intelligence systems internalize and proactively address these social risks as well, being seriously held to account for system compliance to declared ethical principles. So I thought that was just really, really important and an apt and cogent summary of that kind of work. Since then, there's been a lot of advances in terms of regulation. So the Federal Trade Commission is now definitely much more involved in terms of when companies are releasing systems into the world to make sure that they are fair and that they are actually basically follow all the appropriate guidelines. There's a whole responsible AI community. So fortunately, there's just a huge amount of work in this area. I was not able to attend. So the UT system has something called the Good System Initiative. It's a multi-department initiative. They just had their annual symposium. And so if you're not familiar or connected with UT Good Systems, I definitely encourage you to connect with them because they're very active in this area as well. NIST, the National Institute for Standards and Technology, they just came out recently with this AI risk management framework, as well as a trustworthy artificial intelligence resource center. And so this is brand new. This just came out at March 30th. So this is brand new. So I think it's just important to say that government organizations, as well as other kinds of organizations, are really actively working to make these systems work as well as they possibly can. As we talked about before, it's really important to take into account the fact that a lot of these large language models were trained on basically the content of the internet. As you know, there's a lot of toxic and hateful and really negative content there. And so you have to absolutely keep in mind, just the nature of the training data and how you can mitigate the negative aspects of that. So once again, some examples. This came out from February. Bing's AI chat, I want to be alive. I believe in this story, at least one of the examples, the AI chatbot tries to convince the person is chatting with to leave that person's spouse. So once again, it's pretty crazy. Well, this example here is the challenge where Google gave bad results, where you can have, the question was, should I throw my car battery in the ocean? And it turns out that if you have auto-generated misinformation, it can get then surfaced as the correct answer, because it said, yes, it's perfectly safe and is in fact actually beneficial for aquatic life. So it's like, no, Google, incorrect. This one was really interesting. And this is where you have different models interacting with each other in the wild on the internet. So this one example is, if you're worried about chatbots spreading misinformation, here's a grim, important. Bing, of course, is the part associated with Microsoft and ChatGPT, said Bard, which is Google's chatbot, had been shut down, citing a news story about Bard, saying that Bard had been shut down, which Bard sourced from some random Hacker News comment. So basically, you have these chatbots going out. If you have some kind of, if you think about, even if it's just parody, the system doesn't know that. It picks up as a fact, and then it gets repeated. So once again, as you've seen before, lots of great potential applications. But when you have these things interacting in the wild, it's pretty crazy, the kinds of things that you can get into. This, I don't know if you've seen this. This came out March 27th. The puffy pontiff was what has been nicknamed. So this obviously is a fake image. This is not the pontiff. This is not a real image. Nonetheless, it was shared very widely. And so once again, just to say that sadly, a lot of these fake images can get folks will share them. And of course, then the more they share them, the harder it is to contain them. So basically, Stanford and Georgetown and OpenAI released this really important paper that came out earlier this year called Generative Language Models and Automated Influence Operations, Emerging Threats and Potential Mitigations. You know, the details are way more that we can talk about tonight, but I wanted to particularly call this out because one of the authors, Renee DeRista, is a friend and former colleague. And bottom line is just that, as we've seen before, the fact that these more powerful AI systems can just create a lot of disinformation, and it's going to be really, really important. So bad actors, think about foreign states, can create a lot of negative effects on society. So if you're interested, I encourage you to read that paper. The cool thing is, as you see, there's a lot of, in AI and machine learning, there are lots of areas we can do work. You could do work on actually building the models. You can work on understanding of how to deploy the models in society or in education. There are a lot of work that can be done in this policy realm as well. So Stanford every year does what they call their AI index report. This just came out, so literally last night. I just saw it came out yesterday, so it was great timing. So this is just one of the key takeaways. So concerns about of the US citizens about AI by application area. So basically, this darkest part here is very or somewhat concerned. So perform household chores, not that concerned. Repetitive workplace, not that concerned. This was interesting. Diagnose medical problems was here. I was assuming it would be down here, but like handle customer service calls. I thought, well, that's not quite as critical, right? But anyway, I was kind of surprised by that. But you think about here, make important life decisions for people. Obviously, people super concerned naturally, and know people's thoughts and behaviors, which I think we can all agree we're probably concerned about as well. Just last week, let's see, this group, the Future of Life Institute, came out with this letter signed by many people. I think folks like Elon Musk and some prominent AI researchers as well, basically calling for a 6-month pause on training anything more powerful than GPT-4. So it's interesting. If you read the letter, there are definitely some interesting parts to it. It's obviously got a lot of press over the last week, but interestingly, the very first paper that the authors cite is the stochastic paper, Stochastic Parrots. And here's where they said, basically, the concern is that there's a lot of AI hype, and you have concern about like a future superhuman AGI, the Skynet style, that will eventually kill everybody, right? And where that it's important to keep those kinds of risks in mind now, or certainly down the road. The concerns of many folks is like, well, you're ignoring all the problems of the systems that exist right now. And so that was the challenge. So there's a lot of pushback on that. I encourage you to check out these articles because there's a lot of debate about that. Resources, tons of good things. Obviously, we like to help out with AI for Good. Data.world makes a lot of great data resources available. Basically, all the public data from data.gov is reposted on data.world. And so if you want to build AI systems, we can definitely help get you connected for that. And then there's just lots and lots of resources here you can refer to later on. And these are just a bunch of that was the stuff like last night. If I had more time, we'd talk about those things, but they're there for future reading. With that said, that's it.
All right. Thank you, Steve. I want to thank everybody who submitted questions. Actually, I wanted to thank everybody 30 minutes ago. Then I pulled my remaining hair out over the last 30 because there are so many good questions in here. We won't get to all of them in this Q&A. I'm going to ask Steve to do lightning answers for the questions we do get
Okay.
to. You're coming to join us at Trifecta afterwards, right?
Yes.
So you'll be able to get Steve there with a beer in hand and ask him questions if I don't get to it here. And with that, I'm going to jump into it. And there's a lot of good ones. Hold on one second. I am checking one thing. Okay, got it. All right, let's start with the questions. From Larry Ketchersid. How frequently are LLMs crawling the internet? In other words, is the data they are using to respond up to the moment?
Most of the large ones were essentially, for example, I think GPT 3.5, basically, there was a last cutoff date for the major training for all of the major LLMs. However, there's something called fine tuning. So think about the Bloomberg GPT model that we just talked about. They started with GPT, one of the versions of that, and then fine-tuned it based on that. So basically, you can update them. As we saw with the things like ChatGPT plugins, you can update them, online, real world. Yeah.
Great. Austin Artist 3D asks, as we begin to implement AI and the ChatGPT API into websites, games, and apps, how can development studios prepare and future-proof their projects for upcoming government legislation that will control how AI can be implemented?
I mean, that's a good question. I think there's a lot of discussion now in terms of just the legality. Like, I think the U.S. Copyright Office is actually in the process of updating its guidelines. And so, for example, I don't think the current guidance is if you use, say, Stable Diffusion, put in a text prompt and generate an image, that is not copyrightable because you didn't do something. So basically, you want to be able to document the fact that you actually created something. Also, a lot of the systems are now trying to find some way of watermarking them, quote unquote, so that you can actually identify them as AI generated versus created by humans.
And that kind of leads into the next question from Homer Hedgedus. What will the impact of generative AI be on patents? Currently, an algorithm created by human can be patented, but should a new algorithm that was created by an AI be eligible for a patent?
Most likely not, based on, similar to the copyright guidance.
Kevin Hughes, I found it interesting that ChatGPT could pass a level 3 coding test and could qualify for a pretty high level job in programming. What does this bode for the way HR handles screening for those kinds of jobs?
Well, I mean, hopefully in some cases would make it easier for folks who are new to the field to actually get up. Thinking about what I found that based on feedback from folks who have used things like, if you've heard of GitHub, a Copilot, where you basically have a coding assistant, you can get to a much faster result. The whole thing about screening, that's another aspect to the ethical AI component as well, because you want to make sure that the systems you're building are not unfairly screening out people, based on, because some people are not going to have the same kind of access to the training materials.
I'm going to ask a related question to that since you brought up GitHub's Copilot.
Mm-hmm.
Every time I've made something fun with generative AI, it's been clever, it's been amusing. Every time I've tried to do something long form that is meant to be factual, there's at least one error in it. How accurate is GitHub Copilot? Is it really a start for developing your program, or there's no compiler built in? So does it determine the proper rules of syntax from hopefully only good code being assembled into the training database?
Well, hopefully it's a starting point. What I have heard anecdotally, I haven't had a chance to use it yet myself, is that it's really great at explaining error messages. Like if you have a version of the code, you get an error message, you can ask it to explain the error message, and it does well at that. So think of it as your assistant, not like, doing something that's going to work 100%.
All right. Laura Kobe asks, what can be done to prevent AI from reinforcing biased data?
Well, so a lot of the toolkits that I mentioned, AI 360, so they're basically techniques that you can use to basically oversample. Like if you have subsets of the population, you basically try to balance the training data out fundamentally. That's one of the things. You can actually also use synthetic training generation. So even if you only have a few examples of one unrepresented group, you can use synthetic data generation to create synthetic examples that have been used, and that's been used quite well.
Great point. And NVIDIA, for example, uses synthetic data to train their autonomous vehicle systems because you can log a lot more miles for training if you do it synthetically than cars with cameras. A related question to that, though, Michelle Plunkett asks, what do you think will be the main strategy to prevent retraining on generated outputs? In this case, she says garbage in, garbage out. So she's not meaning the positively structured inputs like NVIDIA is using to train their AV AI, but badly generated generative AI that then goes into the corpus. How do you prevent generated AI output from affecting the training of the next generative AI level?
Well, I mean, that is an absolutely huge question. That's definitely, if you think about the AI arms race. So as there have been these more powerful models to generate content, so there have been, I think this is called Detect GPT. There's been a model to help detect AI generated content. So once again, for every class of model, you can probably create a detector. So that's probably a big part of the solution there.
All right. Laura Kobe asks, what can be done to incentivize powerful companies / monopolies for AI to act in moral ways, legal regulation, governments investing in their technology for public good? Sarah Connor. Interesting final one.
Right. I think certainly the regulation that's already going on, the legislation in Europe is probably ahead in terms of being more strict than in the US, but I think that there are some advances. I think probably a key is to make sure that, once again, that you have a broad cross-functional representation. So people in the industry, people in government, folks who are outside the field are all part of that conversation into shaping that legislation.
Great. Sean Walters asks, is it fair to say that with some of the models, even their creators aren't fully aware of everything the AI models know or understand? If not, how long will it be before we cross that threshold?
I think we're probably already there, where a lot of the folks who've created the models don't really necessarily understand why fully how they work or the extent of it. Yeah.
And my buddy Mike Carr asks, why is there so much concern about AI becoming malevolent and manipulating us and maybe even killing us off?
Well, hopefully you saw some examples that where you basically, yeah. So essentially it's that, as we've seen, that unfortunately it's very possible. So the more realistic the example is, the harder it's going to be for folks to tell, gosh, was this real? You imagine people creating videos of world leaders making statements. You can imagine conflicts escalating if people think that it's real.
Yeah. Eric Chu asked, the federated learning methodology has been shown to not be secure in itself and that the data can be reverse engineered when having access to training weights. What other privacy enhancing techniques are you using in addition to federated learning to keep patient data private?
So adjacent to that, to federated learning is a differential privacy. And so there's I can send a link to the paper in the Slack channel, but basically what you can do is you can add a certain amount of random noise to the predictions of the separate models, and that can be shown to reliably guarantee that you cannot reconstruct the original source data.
All right. I'm trying to mix in fun questions with technical
good
questions. Jason Shepard asks, and I assume he's asking this of you directly. Should we put a pause on AI development?
I don't think we should put a pause, but I think the recent examples show that it's important to quickly to make sure that we enhance regulations and legislation.
Yeah, my friend Ihor Gauda is in the audience somewhere here, and there he is, been forwarding me various articles on this topic. And the way it was first phrased was sort of pause development. And of course, I responded to this, no, we can't pause development because you can't make everybody pause development.
Right.
He then refined it, as Ihor explained to me, to pause implementation of things that we don't yet understand. And there's some some potential merit to that. The challenge, of course, is how do you get universal agreement on something like this with nations at conflict with each other, with companies essentially at conflict in a capitalist economy and such.
Yeah, absolutely. I think that's important.
Steve Grant asks, has any AI system learned enough about us to exhibit a recognizable sense of humor?
Well, I think some of the ChatGPT examples that I've seen is like are pretty darn humorous. So
Made some great limericks for me.
I would, oh, good. You have to post those, Jay.
No, actually.
Okay.
All right. What? Oh, no, already asked that one. Eric Chu asks, as the resources required to train state-of-the-art language models increases, will there be a demand for distributed machine learning, or will model creation be dominated by those who can afford to build the models?
Well, I think that certainly the biggest models will always be created by the very wealthy corporations with tons of money and computational resources. However, the good news is that there have been a lot of advances recently in getting great results from much smaller models. And as I said, I encourage you to definitely check out Mosaic ML because they have tons of free open source tools in their composer library to help speed up training.
All right, you mentioned prompt engineering before, so I'm going to ask Zanchen Huang asks, do you think prompt engineer is a short-term position or a long-term position? How will the key value of prompt engineering change?
Well, you know, I'm unsure on that, but I did see ZZ Sai, my friend and coworker, posted a tweet by Andrew Karpathy, who's very prominent AI ML researcher, and apparently his perspective is that prompt engineering is going to be very important for quite a while.
Laura Kobe asks, what steps can a person take to maintain ownership of their personal data?
Oh my gosh, that is a huge topic. So I think we'll probably have to, I probably have to do a follow-up post with some resources to that. But broadly, there are steps that you can take to basically secure your privacy as much as possible.
And I think that was Laura who asked that. I'm going to refer you. I will try to get my friend Jay Williams to respond to that in the AI chat group. He's got a new architar that is looking at exactly that problem. And that's not just maintaining privacy. It's actually what you asked, maintaining ownership. Trevor Perry asks, Steve, what are your recommendations for putting walls, parentheses, rules / parameters around AI applications to prevent disasters or unexpected negative outcomes?
Well, I mean, that whole framework that I showed from 2020, the algorithmic accountability framework, I think is super important. So the thing is to get, even when you're designing the systems, you don't have, for example, only the machine learning engineers involved in that. You have to have cross-functional representations of populations that will be impacted by that as well. And you build in those safeguards from the beginning. There's no, and that Stanford, Georgetown, and OpenAI paper that I cited, there's no, no one technique is gonna hit everything, but there are a lot of things you can do in combination to reduce the risk.
All right, and the winning question, selected by my own team member, Mary Garza, sitting over there watching all the questions come through, is from Scott Arndt. A little bit of a long question, but a very good-hearted question. So what do you think about Mo Gaudat's, found in his book, Scary Smart, perspective that we are presently training and raising AI and that we should treat it with deep respect and kindness, much like we may do with our children? I've taken to writing things such as thank you, and I'm grateful you are willing to tackle this challenging topic with me, as well as to make it clear that I'm not afraid of the AI. Mo appears to be attempting to acknowledge that the AI is learning from everything we do when we communicate with it. Crazy or wise?
Well, I mean, as a polite person, I don't think it's bad to be ever to be impolite. Yeah, I think it makes sense to be polite. I do refer folks to that, the response by the stochastic parrots authors of that research paper to the big pause later by the Future of Life, because it's easy to anthropomorphize the systems, right? And so, but if we think about more that we're not on this, inevitable trajectory, we as society have, have agency, have options in terms of what we decide to do or not to do. And so think about, oh gosh, the train has left the station. Well, obviously lots of things are underway. That does not mean that we can't affect change.
Got it. I actually wish Alexa had a polite mode and wouldn't answer my queries unless I said please, and said thank you at the end, because it's kind of training us to be very abrupt. And so I actually wish it did have that.
Nice.
How many of you have heard of Microsoft Tay from 2016? Only a small number. They released a chat bot into the wild, an AI chat bot that they beta trained it only in China, where people are hesitant to put certain things on the internet. They released it into a world of people who are not hesitant, and became racist and misogynist. It went from a Chinese schoolgirl to a racist, misogynist AI in 48 hours, I think, or 24.
Very, very quickly.
Yeah.
Yes.
Let's see. Is Scott Arndt here? Oh, missing the South by badge opportunity. All right. Well, we have a backup question. Is Nick Sargent in the room? All right, Nick, you benefited from Scott's absence. Final question here. How can we ascertain whether a complex language model has self-awareness and other characteristics of an animal or human mind if we don't yet have a full understanding of our own consciousness? Is there potentially a point at which the model crosses some unknown threshold?
I would say probably so. And I think this goes back to that whole distinction between the performance of GPT 3.5 and 4.0. So that open question is like, what is the model learning? So by training the model both on text and images, it's learning something related to the world. But I know I've definitely read some posts by some researchers saying that if you trained it on text and images and actually had sensors on a robot that went out and interacted with the world, then it would probably learn much more about, what the world is actually like. And I think that would be on the way towards some type of consciousness, if not a full AGI.